Hello and welcome. My name is John Gino Kim and I'm instructor at Elite Institute Academy for Mathematics. Today we'll be going over some problems in SAT Math. Okay, go ahead. So question number 1. Find the sum of all coefficients of x plus 2 to the power of 5. Assume the constant term is also a coefficient. Now, we take a look at this, x plus 2 to the power of 5, and one of the first things that you might also think is that, well, how we can easily find our coefficient by trying to expand x plus 2 to the power of 5. Now, while that is a valid way to do about it, you see, here's the catch. You have, 45 minutes to go over these, 20-something questions, and, trying to expand this x plus 2 to the power of 5 during that time is not the most efficient usage of the time. So here's actually an easier way to do about it. So let's assume about this. Now you see x plus 2 to the power of 5, and what do we know about it? If we expand this thing out, this can be expressed as something like this. A times x to the power of 5 plus b times x to the power of 4 plus c times x to the power of 3 plus d times x squared plus ex plus f. We can assume that this can be expanded in this manner. You see, I don't know what this a, b, c, d, e, f is, but we do know that x plus 2 to the power of 5, because the highest order term has to be x to the 5th, has to be like this. Now, let's think about this. What are my coefficients? A, b, c, d, e, and f, because we assume the constant term is a coefficient. So if we can figure out what this sum of a plus b plus c plus d plus e plus f is, we're done. So, in fact, it would be so nice if x to the power of 5, x to the power of 4, x to the power of 3, x squared, and x all become 1. And let's think about it. What's the best way to make that all of them into 1? If they all become 1, then we just have a plus b plus c plus d plus e plus f. You see, easiest way to make all these powers of x become 1 is to set x equals 1. If we let x equals 1, what happens to x to the power of 5? 1. X to the power of 4, 1. X to the power of 3, 1. X to the power of 2, 1. And x1. So when we set x equals 1, what happens? A plus b plus c plus d plus e plus f, which were the sum of the coefficients we want. Now, let's take a look at this here. We start off with x plus 2 to the power of 5, and we set x equals 1, which gives us sum of the coefficients. So all we really need to do is take our original function x plus 2 to the power of 5 and plug in x equals 1. And that would give us the sum of all coefficients. Therefore, we don't even need to do expansion. All we need to do is let x equals 1, and we would get 3, because 1 plus 2 is equal to 3, and 3 to the power of 5, and that is equal to 243. And that is the sum of all coefficients. So as you can see here, there's no need to really actually expand things out. All you gotta do is realize that when we set x equals 1, all powers of x becomes 1, so you're left with just coefficients, and you add them up, and you get 243. All right, next problem. All right, the next problem, question number 2. The histograms above summarize the distribution of the integers in two data sets, P and Q, each containing 39 integers. In each histogram, the first interval represents the number of integers greater than or equal to 0 but less than 9. Second interval represents the number of integers greater than or equal to 9 but less than 18, and so on and so forth. What is the greatest possible difference between the average arithmetic mean of the integers in data set P and the average of the integers in data set Q? Okay? So, to solve this problem, let's think about something. So, we look at this here in our histogram, data set P, and we take a look at my data set Q. What do you see? We see that if we just take my data set P here and just shift everything by one interval, we get data set Q. Of course, there's a little complication, because it's entirely possible that, for example, in first interval here between 0 and 9, my data value can be different from data values here individually, because they all just include the range. They don't exactly tell you that it's going to be exact shift. However, here's the catch about it. They asked us, what did they ask us? They asked us the greatest possible difference between the average of the integers. That means if I can maximize the difference between each cases, then that would maximize the greatest possible difference in the means. So in order to maximize the difference, which would maximize the mean between dataset P and dataset Q, is that we take a look at each interval that correspond to each other. Okay? For example, like your first interval of 13 values and first interval of 13 values, the corresponding one in dataset Q. Now, how do we maximize the difference? Let's think about it. We maximize the difference by setting all these values from dataset P of the first interval to be as small as possible, while setting the first interval, all these 13 values, to be as large as possible for all 13 values. So what did they say? In the first interval, numbers of integers greater than or equal to 0 but less than 9. That means I can set all these 13 values in the first interval to be 0, while I can set all these 13 values in dataset QB, it has to be equal, greater than or equal to 9 but less than 18, and since they all have to be integers, what's the greatest possible value they can get? 17, because it has to be less than 18 and it has to be an integer, so therefore maximum possible value has to be 17. That means we have 13 zeros in the first interval and 13 17s, and that would be the maximum possible value. Now, if you think about it, there's no difference in the second interval that we decide to pick as well. You see, for 4 values, what's the minimum possible? 9. And for this second value for dataset Q, what will be the maximum possible value? 26. What is our biggest difference? 17. So what we realize is that dataset P to dataset Q, how do we do it to maximize the difference? We shift every single one of these data values and shift it by 17. So we have shift of 17 for every data value, and we would go from dataset P to dataset Q while maximizing the difference. So let's think about it. If we know shift of 17 of the data value, then what do we know about it? Every single data value just got shifted by 17. That means the difference between them would be 17. And what do we know? What happens to the shift? That is, if we just shift every single value by a certain number, then that also becomes, what is it? The difference in mean of the certain value. Therefore, my answer is 17, and it's really easy because if every single value, you see A1 through AN, right? And we get the B1 by A1 plus 17 to all the way to AN plus 17, then guess what? We know here our sum is going to be, our average is going to be A1 plus AN over N, while here, what is it? My sum would be A1 plus all the way to AN, and then we have 17 times N, because every single possible has 17 in it, divide by N, and what's the difference between them? It's 17N over N, which is, so the difference is equal to 17. Therefore, 17 is the maximum possible difference between the average of dataset P and average of dataset Q. Okay? So here, while this problem looked complicated, it really is not very complicated at all, because only thing that's useful is that when you see, this was the keyword, greatest possible difference. That means minimize all data value in P while maximize all data value in Q, and doing so, you do so by simply making a shift of 17. And if every single data value just simply gets a shift, you know that is a difference in the mean. Okay? So therefore, answer is 17. Okay? Thank you.